Today we will be studying about the signal flow graph. Till now we were studying about the block diagram reduction, finding out the transfer function using block diagram reduction. Any given system can be represented in terms of block diagram, and by applying the block diagram reduction rule, we were finding the transfer function. But that was little tedious, the process. We had to apply the rules, we had to shift the summing points, take off points, and a lot of parallel and series combination was to be done, and then finally transfer function was found. But if the block diagram is little bigger, the system is complicated, the block diagram becomes little bigger, and the reduction process also is little tedious and it is complicated. To reduce the complexity, a simpler method was developed by S.J. Mason, which was called the signal flow graph. The signal flow graph is a graphical representation of the system variable. And from the graphical representation using the Mason's formula and applying that certain values into the Mason's formula, we can find out the transfer function easily. And the signal flow graph can be obtained from the block diagrams, or it can also be obtained from from the system equation. If we know the block diagram or the system equation, we can write the signal flow graph. And from that, it is applicable only for linear systems. The component of the signal flow graph will be the nodes and branches. In this diagram, these are the nodes here. This 1, 2, 3. They are called the nodes, and branches are these lines are called the branches. That is the line which is coming from 1 to 2. It is called the branch. 2 to 3. They are all the branches which represents the signal flowing. And the signal travels along any branch, and it is multiplied by the gain. If there is any gain here, that the signal gets multiplied by the gain represented above. The value of any node variable is the sum of all the signals entering the node. For example, here if there are two signals entering this node 3, it will be equal to, the gain will be equal to G2 as well as equal to G3. It will be equal to sum of these two, that is entering G2 plus G3. Similarly, if there are two signals entering to the node 2, it will be equal to the total signal value that will be coming to the node 2 will be equal to the one which is entering here as well as the one which is here. Now, coming to this graph, coming to this here, coming to this block diagram can be represented using this signal flow. We know there are node 1, 2 and node 3. Write 1, 2 and 3 here. From 1 to 2 there is a signal flowing and the gain will be G1. So there is a signal. The signal is represented by a straight line and the arrow represents from which node to which node the signal is flowing. Here the signal is flowing from 1 to 2. So we write an arrow and show the arrow going from 1 to 2. And the gain of this will be G1. It is getting multiplied by G1. So we write G1 on the top. Similarly, from 2 to 3, there is a signal going from 2 to 3. So we write a straight line and the arrow in the direction of 2 from 2 to 3. And it gets multiplied by a gain of G2. So it is again multiplying here also, the value will be G2. Whereas here there is a signal going from 3 to 2. Here the arrow should have been like this. The arrow should be like this. In fact, it should have been like this. It is going from 3 to 2 and the gain will be G3. Where here in the bottom from 3 to 1 there is a signal flowing. It is going from 3 towards 1. So we write a line and write an arrow which is representing from 3 to 1 and it is getting multiplied by a gain of G4. Similarly, in the next one, in the second one, we see there is a here it is coming. You can show like this, or you can, if there is a signal which is coming here, it again gets summed up here. The previous one there was no signal from this end, whereas now there is a signal from this end, so we show a summing point. And here if there is no signal, it is not getting multiplied by any gain. If the signal, the gain is just written as 1 here, that is, it is just coming means the gain will be only 1. Whereas here also, that is here from this node from 1 to 2, again we see there is a signal flowing and it is getting multiplied by G1. So we write a line from 1 to 2, arrow with arrow in this direction, 1 to 2. The arrow will be from 1 to 2. The arrow will be from 1 to 2, and again from 2 to 3 there is a signal flowing, and with arrow facing 3, the gain will be G2. Whereas this, again as we discussed previously, it is going from 3 to 1, 3 to 1, and the arrow will be towards 1 because signal is going towards from 3 to 1. Similarly, if we have equations, suppose we have equations here. I'll zoom it if it is not visible. If there is equations here, you see x3 is a x1 plus b x2. Then x3 is a x1 plus b x2. So there is to x3, you have x1, there is a signal x1 which is coming, which is getting multiplied by a gain a, and there is a signal x2 which is coming, getting multiplied by b, and both of them, they are coming from towards x3. So the arrow will be in this direction. You'll have to draw the arrow like this. This will be the direction of the arrow. Here also the direction of the arrow will be like this, from x1 to x3, from x2 to x3. So here the total value that is coming here will be two values, that is two signals, a x1 and b x2. Now this can also be represented. Suppose your x1 and x2 are equal, so it is a x1 and b x1. If both of them are equal, that is if x2 is equal to x1, then this point can be connected like this, and it is the same signal which will be coming to x3, but it is getting multiplied by b in the second case. Now coming to this one here, to the next one, here it is x2, there is a signal which is coming from x1. So here it is, the signal here is x1, x1 into a is coming to x2. The signal here is x2. Towards x3, what is the signal coming is x2 into b. So it is total signal that comes here will be ab into x1. This will be ab into x1. That is to x2. x2 will be equal to a x1. And what is x3? x3 will be equal to b x2. Now when I am substituting the value for x2, it will be a x1. So finally whatever signal comes towards x3 will be, this is x3 actually, x3 will be, it is a b x1. This value, this has to be x3. When you are writing down, please write down all this in the notes as we are discussing. This has to be x3. This will be x3. Write all this in the notes. Complete the notes before you come to the class next. So now this is how we draw the signal flow. And to the next one now, feedback. How to represent a feedback will be from x1 to x2. There is a signal flowing and the gain is a. Again there is a feedback from x2 to x1, and the feedback can be either plus or minus b. So this equation is similar to what we did in block diagram reduction. It becomes a divided by 1 plus or minus ab, divided by 1 plus plus or minus dh, where g is equal to a and h will be equal to b. This is the self loop. This loop is called the self loop here. This one is called the self loop here. And here this value here, the self loop is, it's like if suppose I'm having I'll just try to draw it and show how it is actually. Suppose self loop means it will be like this. We are drawing this value will be b here. This value will be b. This value, the gain will be b here. Then the same thing goes, and from this there is a feedback. There is a feedback like this. So this will, if this is a negative feedback, then what will be the value here? This how do we represent it here now? This is b, that is here the gain, that is this value is b. It is like this. So here this value, this is b. So now the gain of this value, this one is here, it is 1. So gain is 1 here. So now what will be the equation for this system? It is going to be 1. The equation is 1 divided by 1 plus or minus. Suppose this is negative, it is b. The equation, this will be the equation for this self loop, and then it is getting multiplied by a. This, and there is a equation, there is another signal that is coming here. This is a, the signal that comes here is a. So this it is getting, so the total equation will get multiplied by a value a. Next, coming to the next one, this value, what is x4 will be, as we have seen in the previous one, x3 will be x1 into a, and x3 is also equal to x2 into b. This x3 is, again there is a signal going from x3 to x4, and it is multiplied by c. So x4, finally x4 will be equal to, this is x4, which is c x3. This value is x4 here. X4 will be equal to, this is x4, which will be equal to x4, which will be equal to c x3. So finally x4 is c into ax1 plus b x2. So you multiply, you will get this value. Again here, the next one, this is for how we have to draw the signal flow. Then this is a feedback. So what will be the equation for the feedback here? For this loop it is going to be b divided by 1 plus bc. This getting multiplied. If this is a positive, negative feedback, plus if it's a positive feedback, minus. This is a positive feedback because I have not written. If it is a negative feedback, we'll write it as minus c. Positive feedback is plus c, and if it is positive feedback, here in the equation you write it as minus bc, and then this entire equation gets multiplied by a value a. So this is the equation for this signal flow. And next, coming to the next one here, this is if we have a block here like this, then this block